get started. Trends in AI, the first edition for 2024. Happy New Year, everybody. And we're gonna try to make some sense of the dense space of acceleration that is still surrounding us in AI. I'm Jakub Zavrel, founder of Zeta Alpha, and with me.
Hi, everyone. I'm Dinos. I'm doing AI research in information retrieval at Zeta Alpha.
And we have a remote panelist, that's Rodrigo. Welcome on the show. Can you introduce yourself?
Hi, everyone. My name is Rodrigo. I'm a scientific advisor for Zeta Alpha. Nice to be here. Yeah.
Okay, let's get started. So I think this year over the holiday dinners, I did not have conversation about AI. I think there's a certain sense of AI fatigue in the general population, but that does not mean the developments have stopped. What's your take on this?
Yeah, it also didn't involve too much of AI to my non-AI friends, just to be out of courtesy to them. But we see a lot of stuff every day, especially on Twitter, and of course, Archive is not slowing down at all. So we've, again, like every month, we've gone through the papers and the news. This time, we're going to spice it a bit up since it's the beginning of the year. So we'll also have a kind of looking into the future, what might happen and what we'll see.
The crystal ball of 2024. Well, we have tried to make the predictions quite specific. We have 10 of them. And let's evaluate 1 year from now how many of them were actually true. We're cheating a little bit here and there.
Yeah, so we're kind of basing ourselves off of news and off of recent research work. So it's not entirely opinionated based on our beliefs, but some of them are. So,
and as you know, humans have a very good sort of sense for linear evolution. But when it comes to exponential acceleration, we're just kind of hopeless. So let's see how where we go. Our prediction number one.
What else could it be?
What else could it be?
The theme of the year.
So we feel that especially open source, right, has crept up very closely on OpenAI's hegemony.
Yeah, it's true. I think this week the chatbot arena, they released an update on their rankings, which they basically show Mistral, the proprietary model they have, but also the open source.
The medium one, right?
Yeah, but also the Mistral Small, which is their mixture of experts, seem to be outperforming Claude on the upper end and even ChatGPT 3.5 for the open source one. So that's really exciting news for people that want to use them and deploy them locally, but maybe not so good news for OpenAI, who may or may not be sitting with their hands crossed. What do you think?
I don't think so. So my specific prediction is that it will not be 4.5, it will be 5. GPT-5 will come out. And my specific prediction, it will come out before the end of March.
Mm-hmm. So a 1-year development life cycle.
Yeah. So, you know, they have these thousands of GPUs in Azure data centers. Of course, they've been kind of sneaking them out to actually serve the model to customers. But I'm sure they kept a few 10,000 of those GPUs to actually be training the next model.
Mm-hmm.
Just one thing, these slides are, I think these slides are not showing up. The next one.
We're still on the slide with the Q-star model.
I'm still seeing the first slide that trends in AI January to 2024.
Oh,
maybe it's just me, but
all right, I don't know. Let me try to fix that. And while I try to fix that, Rodrigo, what's your prediction for OpenAI's next product release?
Yeah, I think it'll be GPT-5, like you said, not 4.5. I'm not super optimistic that it'll be released in March, simply because GPT Vision was just released a few, how was that, like 3 months ago? So yeah, my prediction is that GPT-5 will be released in 8 months from now, more or less, and it'll be quite great, I think, in terms of generate longer and longer outputs. Namely, I think it'll be able to write multiple pages of code, multiple pages of documents, of course, with some mistakes here and there, but I think it would be much better than what we see currently with GPT-4. Yeah, it works now. Yeah, it's working these slides. Yeah.
And so, Dinos, what you put here some rumors about Q-Star. What's
Yeah.
your speculation there?
I mean, Sam Altman himself, he didn't confirm or deny that they're working on it. So I think by doing that, there is indeed some merit that there was a project internally that used Q-Star. What that may mean is still unclear, but most people are speculating it's maybe some Q-learning and an A-star combination. But either way, they're not committing to one project that will lead the jump forward. But in any case, they're definitely working on something. They have a ton of researchers from a lot of top-tier labs. So I'm sure they're doing something more than just public-facing products for commercialization. At the same time, I'm a bit more pessimistic that it's not going to be 5 from the beginning. We might see 4.5 in the next few months, and then maybe end of year have a really early sign of what GPT-5 can do.
And what do you think? Will it be a gigantic model, or will it actually kind of, we've seen this sort of trend where higher quality data and smaller models and maybe mixtures of experts of really small models are kind of beating, right? The Mixtral model is a 8 times 7 billion parameter model. So what's your kind of idea of where this could be going for the next sort of qualitative leap?
Yeah, that's a good question. I'm not sure if for the size, because we still don't know GPT-4 exactly. It probably is a mixture of experts, but we don't know how many experts, how many parameters per expert. What I'm sure of is that OpenAI has been seeing a lot of the development in open source, and maybe they've used a lot of tricks under the hood to make GPT-4 to begin with, but maybe they get new ideas from open source that they will start incorporating. So maybe some of the stuff that open source has been pioneering is going to go back to the closed source and improve that even further, because we've seen how much we can go from the traditional Llama 1 architecture and just doing many more tricks. We can go to Llama 2 and Mistral and so on.
Yeah, so you think actually sort of this whole storyline about scale and scale being everything was kind of misleading, and it was just the scale of the number of tricks.
Yeah, for GPT-4, maybe it's probably the case. So I'm thinking GPT-5, if it does come this year, it's probably going to be how many tricks can we get to work at the same time, given the limited number of GPUs that they have, because they haven't announced really that they're doubling in size from what they had trained GPT-4 on, but also the same amount of data is probably, as we'll see in the next few slides, they're actually losing their sources of data and not getting more exponentially as they were.
Right. So the tightest prediction is end of March. The longest is
end of year.
End of year. So that's a pretty broad range. I think we're cheating a little bit here on the specificity. All right, so let's move on. Actually, there was this rumor just this morning where Sam Altman himself.
It's not a rumor. He said in a very broad marketing speak, you should prepare for GPT-5 and AGI relatively soon. But that could mean from one day to an eternity. So,
yeah, maybe he's taking the same kind of time range that we just discussed. But it could be tomorrow. Who knows? But there might be trouble on the horizon, right? So basically, the New York Times has submitted end of December this lawsuit, or filed this lawsuit, where they're accusing OpenAI of copyright infringements, right? It's pretty clear that some source material from New York Times and many other publishers was used in training GPT. And what they're demanding is not only a compensation, but the destruction of all models that have potentially been trained on New York Times. So this could mean the end of the OpenAI product, right?
And not just OpenAI, because a lot of the open source models, the pilots so on, they have most of their English data comes from Wikipedia, New York Times, Washington Post, all of these open, accessible platforms with news in English, high quality data. So, and it's not just OpenAI, of course, we see the instability and image generation, all of these models, they need data, and the most high quality ones come from providers like Getty, news articles, social media networks like Twitter, Reddit, that all of them been closing down on how much they provide for free and for everyone that's not a human.
Well, everybody's trying to get paid. So actually, OpenAI has made deals with Springer to license their content for training. But rumor has it that the amount of payment that they're offering publishers is between $1 and $5 million a year, which when you think that the New York Times has a revenue of about $2 billion, it's not that big of a driver for them. Mm-hmm. So I think definitely New York Times will persist in their lawsuit, and they might even win it in an initial case. But I just don't see this stopping the development now. Like the potential impact to a company like Microsoft of having to remove these products from their cloud offerings. I just cannot see that.
It's quite a setback, right?
Yeah, I just cannot see that happening. And immediately you could get a open source model where just the New York Times was crossed out, spun up. So yeah, I don't think this is going to happen. Rodrigo, what's your take?
The same thing. I think the technology is too sweet for them to stop. I mean, there'll be some lawsuits along the way that might slow down the progress, but I mean the development, not the progress per se. But yeah, I also agree that it won't be stopped by that many lawsuits. Yeah.
Yeah, but it could have a really interesting effect on some of on sort of the balance between the proprietary models and the open source models, right? I think the open source models, in some sense, they are much less vulnerable to this kind of speculation about what was in their training data, because it's kind of out in the open. All right, so that's our prediction number 2. It won't stop large-scale generative AI pre-training. What we're seeing on the hardware front is some really interesting change. So we've been reporting again and again on the dominance of NVIDIA, but just sort of late last year, AMD finally announced general availability for their competing product, MI300 series of GPUs. And in the earnings call, I think it was late November or December, AMD's CEO confirmed that they have $2 billion of solid bookings for their new GPU chip. So clearly, this being in an earnings call, it cannot be just speculation. It has to be really confirmed contracts. And they have said that both Microsoft and Oracle and Dell are going to be shipping products with this new chipset, and that amounts to, somebody did the math. I think the card will be quite a bit cheaper than the NVIDIA H100, so about 50% cheaper, and that amounts to about 500,000 GPUs pre-ordered. So that's still kind of a fraction of what NVIDIA is shipping, because I think they sell that many GPUs per month, probably. But that still amounts to something like 5 to 10% market share within half a year or something like that. So I think that's a start of a serious competition.
And I think what's good for them is they get all of this ecosystem built around their hardware for free. It's not like AMD is going to invest so much into getting hardware support and software support. So we saw, for example, they're partnering with Hugging Face, and there's a huge open source community that wants to integrate their hardware, be it either their processors or their GPUs, to get efficient inference on local hardware, like consumer grade hardware. So I think that's also going to play a big role, because the market is so competitive. people want to find GPUs and they just can't because most of them don't have a large budget, and the cloud providers are kind of stagnating at this point on how much NVIDIA can provide them with new hardware at the right pace. So another huge provider coming in like AMD, I think is going to be beneficial for people that want to develop and just looking for the compute needed.
We have a question from the audience online. Let's see if we can do that. Mark Drees from the online audience. Can you put your question in the Q&A?
Where was the message in chat?
Is there a message in chat? No, maybe you can write the question in the chat and we can answer it a little bit later. All right, so that's our third prediction. 5 to 10% market share for AMD, and maybe some new upstart. There's certainly a lot of startup competition in the AI accelerator hardware space, but a lot of these have been fairly marginal so far. Yeah, everybody's wants to buy these GPUs mainly to train large language models, but there's one other problem apart from running out of GPU capacity. It's running out of training data. But do you think that's okay?
It's definitely a factor. So in my mind, when I'm thinking what the next generation of GPT models can do, one of it is what new training data are they going to pull that they didn't use for GPT-4 already? Maybe it's the preference data and the higher quality that they want to bring in, but most definitely we're going to run out of internet data to crawl. Human-generated internet data, because that's also another concern. But maybe at the same time, it's not a problem. It's not definite that using non-human data is going to be detrimental to the performance of the model. And there's definitely been research around that confirms and supports this hypothesis. So what people are thinking nowadays, especially with all the new models that come out that use GPT-4 data as a part of the training corpus, is that maybe synthetic data is all you need. Maybe you can use actually synthetic data from the same model in a self-distillation or self-play manner, and this is enough to kind of go along the scale axis where we need larger models, and for these larger models, we can provide them with some part of the traditional human data, but also augment this data with paraphrases or continuations and new variants that we haven't seen from synthetic models so far. And in the self-play paradigm, I think what has been shown in the past in reinforcement learning, where the agent kind of explores the environment and then generates data based on its observation and its reactions, and then uses that data to improve itself. So people have been speculating Q-star might be about this, but in any case, this paradigm can be promising, and we're going to see a few papers now that actually use synthetic data effectively to push the state of the art further. Because we've also seen this in the past months, even with vision models, just generating ImageNet data and training on that help improve on ImageNet score.
Yeah, and so I think if we take this prediction seriously, and we think that GPT-5 is going to be the next best sort of highest quality model, the hypothesis here is that also that one is trained on synthetic or self-play data, and maybe it's Q-star, who knows? So the general idea is that obviously on games like chess and Go, etc., the self-play has achieved phenomenal success, but nobody has really been able to make it work for large language models yet, right? Like how do you create this sort of virtuous loop where the data becomes more and more useful over time? But there's a few yeah. So the question is about the previous slide. Mark Drees is asking about the copyright. So it's more a comment.
Yeah, the judges won't really care for Microsoft's benefits. I guess you could say that the judge should be very objective and say, if you're violating the law, then you should be punished for it and take the further consequences. But I'm not sure if it's that simple because, well, OpenAI makes an argument that it's not exactly a copyright violation and that memorization is a problem because in the original lawsuit, I think New York Times says here it outputs exactly the same article as the one we wrote. So that's an offense. But just seeing that a piece of text during its training, if it's never going to produce it verbatim, then maybe that's not a problem anymore.
And also copyright law is something that can be changed, right? Under this sort of huge economic pressure. Actually, in Japan, copyright law has already been changed to explicitly exclude this kind of training data usage. Coming back to the idea of synthetic data and self-play, there's been quite a significant breakthrough over the holidays in our own field in information retrieval. So we've been looking at synthetic data for fine-tuning dense retrievers and re-rankers with our imparse model. But this one is really quite a bigger breakthrough on the leaderboards.
Yeah.
Dinos, you've dove into this paper, so can you explain a little bit?
I think
what it's about?
The novelty of this paper comes because it's hitting many fronts that haven't been done that extensively in the past. Namely, that first it uses a language model as its base, as its base to train on.
A generative.
It's a generative language model which is based on a decoder-only architecture, while traditionally most encoders, most embedding models use BERT, which is an encoder-only that cannot generate data autoregressively. So what they do is they take this huge 7 billion model, and specifically Mistral, and they generate synthetic data with proprietary models like GPT-4 and 5. And this synthetic data is in the retrieval nature. So they've prompt in a two-step manner. First, generate examples of possible retrieval scenarios, like I have a book and I want to find it by its tag or by its categories or by the author, and then take in this prompt, generate another completion with a proprietary model containing examples that they will be used for training. So you get the scenario that you want to target, and the language model comes up with a completely imaginary query, positive document match, and a hard negative that is relevant to the query, but not actually desirable as a result. So you can.
So there was one really big difference between this and earlier work is that actually not only the queries and the documents are generated synthetically, but also the hard negatives, right? So is that kind of the cause of the success here?
Well, I'm not sure if the synthetic data at all is the cause of the success. Probably, to me, most of the gains might be coming from scaling it to a 7 billion model with a 4,000 embedding dimensions, because prior work doesn't really scale to that level. But what they do is they generate a ton of synthetic data, approximately 500,000 across about 100 languages, covering even languages with very low resource data on the internet. So you would not be able to find data sets, retrieval data sets for those languages, but with a generative model you can. But then they sprinkle about 3 times as much as with real retrieval data. And this is what actually gets them to perform so well. So if we see their performance, it's actually true that it beats the state of the art. So on the beer benchmark and generally on MTEB, which tests other capabilities, not just ranking, but also clustering, re-ranking, similarity, and all that.
So I think the column to look at is here, the retrieval 15 column, right? This is
so this corresponds to beer.
More or less the beer benchmark.
Yeah. And there we see that indeed, when they use all the synthetic data they generated and all the actual retrieval data sets that are, some of them are, they use training splits from data sets that are in beer and other collections. They're obviously fine-tuning a huge model given that they do it right. Also, a lot of tricks involved to actually fine-tune such a huge model with LoRa. But given all this huge process and the know-how, they actually beat the state of the art. So that's definitely a breakthrough in that actually the decoder-only model has been transformed into an embedding system. But we also see in the lines below that only using synthetic data or only augmenting with MS Marco, then the progress is not as great. So in my opinion, is not mostly coming from the synthetic data, which is what the paper is titled, but it's actually managing to scale it to a 7 billion model. But still, on the competitive side, they benchmark against other proprietary models, which of course, some of them are also huge and also train on any kind of data they want, and they seem to be performing even better.
Yeah, I think OpenAI's ADA 2 model is around the level of 50 on this retrieval benchmark, right?
On the table below, yeah.
Oh, it's on the table below, yeah. So it's around 49, and this is really a big change there. Rodrigo, what's your take on this paper?
So I found it really interesting that in the past we were only using encoder-only models such as BERT to act as in the role of encoder. But then at some point we start making progress on the encoder-only architectures, and we couldn't scale it further. And I was always the opinion that because of the bidirectional attention of the encoder-only models, they would prevail, especially in the retrieval task, because we have access already to the entire query, entire document. But then simply because we stop making progress on encoder-only models, then we resort to using these larger decoder-only models. Like there's some rumors that a Mistral is trained on 8 trillion tokens. We couldn't do this with encoder-only models. And I think it's quite nice to see this now. It's we are able to finally use decoder-only models. And I think for the future, because of its size, we'll be able to have a much better out-of-domain performance, such as in domains that are pretty hard, like chemistry, legal domain, the health domain, things like this.
So I have a somewhat more conspiracy theory type of take on this paper, because actually in this sort of two-step prompting strategy, it sounds a lot like beer hacking actually to me, because as you know, some of the data sets in beer are very counterintuitive in terms of retrieval setup, right? It's like Arguana, it's like find the counter argument, right? And I think what they do here is that they kind of accidentally generate synthetic examples which happen to be counter arguments. And I think this makes a really big, apart from the scale, right? The scale, I definitely don't disagree with that, but I think just this sort of slight edge on these very peculiar data sets that they generate with this data might actually just be the sort of cherry on the cake that we see here. Would you agree with that?
I mean, it plays a small part. I agree that in general, if you just ask a huge model that has been trained on the internet to predict tasks that might occur on the internet, this counter-argument retrieval or other retrieval tasks that are not the definition of, we have a query, find 10 documents that match that query semantically, then you'd get more data like that. But yeah, I tend to believe that this could be a factor, but it's even more evident that they use 13 data sets, out of which I think 5 or 6 use the train splits from the ones that you test for in peer. So they're not even trying to hide it that much, I think.
So you had one more graph here. What does that show?
They use this in the paper to motivate why they went to this 7 billion model. It's not that they mostly cared about the scale, but they said we care about the diversity of the data it was pre-trained for with. So it's a language model, and it's seen all of the internet, so we no longer need to do that expensive contrastive pre-training step that E5 traditionally does. But at the same time, this figure shows that they try to bring the benefits again to an E5 large style model. So they take XLM Roberta and train it on the concatenation of the real data sets and the synthetic data. And they show that with this orange bar on the leftmost, the performance is actually pretty similar to what E5 large multilingual did. So Of course, they show in this plot that without doing the contrastive pre-training and with contrastive pre-training, E5 large benefits, but at the same time, it doesn't benefit from the synthetic data.
Yeah.
So of course, it could be due to the smaller size. We know that larger models can take in more data more efficiently and memorize and learn all the intricacies, but at the same time, not for retrieval.
Right. So basically, this is a paper which really strongly reinforces this idea that synthetic data will be the basis of the strongest model out there, really potentially making a breakthrough in semantic search capabilities for natural language questions and all those kind of things. It's not entirely practical yet, right? Because I think the current generation has been like embeddings up to 1,000 dimensions, vectors up to 1,000 dimensions, and models which can run on a sort of common GPU or even CPU. And this model really kind of, goes one order of magnitude beyond that. And I really have to see still whether that's really feasible in sort of normal IT environments of companies which want to index their data.
There's a question in the audience about which LLM for the Dutch language is the best one. You guys know any? I can.
For the Dutch language.
Yeah.
I think definitely GPT does pretty well on the Dutch language. We have not seen any sort of major defects there. I know there's a large national initiative starting this year on GPT-NL, run among others here by Surf Sarah and government research organization TNO. But yeah, this project has just started, and my prediction would be that it's actually the sort of large open source models like Llama or Mistral that are kind of specialized a little bit more or fine-tuned a little bit more on the Dutch language, but that there will not be sort of national new models trained from scratch. So I don't know. We haven't tested how well Mistral does on Dutch language. Does anyone in the audience have a clue on that?
It knows some Dutch.
It knows some Dutch. There's definitely Dutch in the training data. But for now, for building a practical system, I would go with GPT-4. It's pretty good in Dutch. All right. Thanks for watching the online questions, by the way. Moving from synthetic data to self-play. This idea of not only generating synthetic data, but generating this kind of reinforcement-like, learning-like setup where models teach each other as they go and make the progress more useful to each other as they progress in the training. Rodrigo, you've read a couple of these papers that just recently came out.
Yeah, so there's this first one that in the sense the method is that you have a single LLM that plays two roles. The first role is what they call the main player, that whose task is to assign a high probability to the ground truth completion for a given question, and a low probability to completion that was generated by itself in a previous iteration. So what it tries to do is to represent better the real human-like data, and whereas downplay its earlier version of the data that it generated itself. So this is the main character, and there is also the opponent character, which is simply the same LLM but in an earlier version. And this LLM, it produces this completions for the same question. So what they do, they start to play against each other, similar in a sense of GAN, that the model first, the opponent generate questions. There is the ground truth. The main player learns to put more probability on the real data and less on the opponent data. And then the opponent tries to make its answers as close as possible to the human data. And yeah, they
So you
keep
do
playing.
need, you do need actual human preference data to get this process started, right?
Yeah, you use initially some ground truth completions that are based on human generated data, but then the idea is that the model gets better as it generates a harder and harder completion so that the main player has a harder time into distinguish between the human generated data and the data but generated by another LLM, which is simply itself in an earlier version.
Yeah,
And
it's in some sense a really kind of similar to generative adversarial networks, right? In this kind of this artificial discrimination task.
yeah, it's pretty similar, and the idea is quite nice. One caveat that I want to mention about this paper is that because there are so many papers being published these days, it's hard to keep up with which idea works best. And in their study, they use a pretty weak baseline for the supervised model. So they showed an improvement on the MT benchmark of 10%. But then if you look what was the baseline is a Zephyr model, but it's a very weak Zephyr model, a supervised Zephyr model that I think they didn't train it well. So my point is that yeah, we need to pay attention. We normally look at these curves that improving, but maybe if the baseline is very weak, we won't see the same gains if we had a stronger baseline. But
So can you explain a little bit based on these graphs what the baseline is?
so the baseline is the Zephyr model trained on supervised data, the 58 points that it gets on the first chart, the top left one, the top right one. And but actually, if you look, if you use I use the Zephyr trained by Hugging Face, it's much better than this. I believe it's around 61 or 62. So I haven't played with this self-iteration method, but it might not be as shiny as they show in the paper. But I mean that's just a minor detail, but sometimes it helps to decide which method we should tackle next.
All right, so you think the actual baseline is actually more around 61 here.
Yeah, that's right.
So that the curve would look flatter and much less impressive. But basically, they do show this pretty neat progress on multiple iterations. So it's not just a trick which works once, but replacing the opponent model with the earlier version of the main model is seems to somewhat work. In fact, there's this other paper from DeepMind, which does a similar trick, but their curve was much flatter. So did they just use a fairer baseline, or are they actually displaying a less potent idea here?
Yeah, this one is quite interesting as well. So in their case, they don't use any human generated data. So they wanted to do in a very puristic sense of only generating answers from the model itself. And these are the tasks that they tackle in this paper are math related tasks. Um, and what they do is a very similar thing that we have a model that generates some completion, some candidate answers. Then we have a reward function. In their case, the reward function was quite simple because it's a math problem, so you can arrive at a deterministic answer. And they use this deterministic function to score the quality of the answers produced by the model. And then they select the best answers to train the next generation of the model. So it's a kind of how should I put it, the batch reinforcement learning setting in which we don't update the model for each training batch. We just run the model for an entire data set, collect rewards, and then select what are the best examples and reinforce the model to perform that well on the next iteration. So the main difference of this paper in comparison to the previous one is that it doesn't use human generated data. It just bootstraps into arriving at the correct answer. And in their setting, they didn't have to use any LLM-based reward model like the ones using RLHF. They could simply use a much simpler reward function.
And the catch is that it only works on problems which have this sort of strictly defined type of correct, incorrect binary classifier on the output, right?
That's correct. Although I think that if you have already some ground truth answers generated by a human, you could use an LLM as a judge. So you give the answer of your model, the correct answer according to a human, and then the LLM judges it and outputs a reward. So I think it shouldn't be a big problem to transfer this method to other tasks.
Which is a little bit what they do in this next paper, right? That's kind of has this whole cluster of papers around this theme. REST meets React, self-improvement for multi-step reasoning in LLMs.
Yeah, and this one it's quite interesting as well. And they use at this time a much harder task that involves search. So you have a question, and this question usually needs to do two searches. Like you cannot simply type one query and have all the relevant necessary information to answer that question. So it needs at least two according to their construction, and or it needs some reasoning steps. Um, so this is the test that they tackle, and they use a search engine coupled with the LLM to generate candidate answers. Then they use the LLM to score those answers generated by the model. Then they take the top scoring ones and fine-tuning the LLM itself in this next iteration. So that's the improve step that they highlight in the paper. And then they keep iterating. Usually they don't iterate them many steps, like usually 2 or 3, they already reach a plateau. But it's quite nice to see that the model is generating candidate answers, and in a way we're using the model itself to improve.
So do you see some kind of sort of synthesis between these three papers? Because they're all kind of emphasizing a slightly different aspect of this self-play idea.
Yeah, and I think it's like we have the self-play that we want to reinforce the model to make again to answer again things that it got it right in the past. But one powerful thing about this style of techniques is that it allows you to explore more your environment. So in the case of if you're generating math-related tasks, it allows the model to see different types of answers. If you're using a search engine, you can navigate the web in order to see more about the world. So I see all these as some rudimentary ways in which, like you alluded to early on, GPT-5 could be used on to gather more data, more interesting data or high quality data. Like it's just the LLM itself decides what it will see next. Yeah.
Anything you want to add to that?
Yeah, I'm sure this is a lot of good ideas for proprietary behemoths to try and get the edge over everyone else. Yeah, I think we should move on.
All right, let's go to the next one, multimodal models, especially text to video.
Yeah, for me personally, I would not expect this kind of quality that we see here so early.
I think one of our 2023 January prediction was that we would have sort of full video clips generated by these kind of diffusion models. I think we're there now, right?
Yeah,
we were right.
That is true, yeah. And in general, we see a trend where people are building models with multimodality in their core principle and not just an ensemble of models that this component, this frozen tower does embeddings for images, and this other tower does something else with those projections. And this is like Gemini is the truth to that they built it from the ground up with multiple modalities, both as input and as output, as demonstrated by their fancy marketing demo. But we do see that a lot of these models are starting to get to the point where people were impressed with the language generation capabilities of ChatGPT. So our prediction for this segment is text to video, and in general, multiple modalities in and out models will finally get their spotlight in 2024. And we have some very interesting papers that demonstrate this.
And do you know what Runway is using actually for generating these videos?
I think they call it Gen 2. Is their proprietary diffusion model.
It's based on diffusion models.
I think so, yes.
Right. So a couple of very interesting papers just came out, which capitalize a lot more on this sort of central transformer block, which can take basically in the spirit of large language models things to a super large scale, but also combine modalities as tokens, kind of on a single conveyor belt. This one just out in, I think, end of December, introduces a model called EMU. EMU, not to be confused with the same name, similar named model by Meta that came out in October, which was kind of a high quality image generation model. But this Chinese EMU model actually puts a pre-trained large language model, namely Llama 33 billion model, at the heart of the whole system, and just basically adds different types of tokens to the existing Llama embedding space. Tokens generated by CLIP on the encoding side, and tokens that come from Stable Diffusion on the output side. And then they train this model end-to-end on a whole bunch of multimodal corpora. And because these are just tokens, they can kind of mix them up in arbitrary ways. And that yields very nice properties. The encoder-decoder model itself is kind of trained to in a kind of auto-encoder like separate loop. So the clip and the Stable Diffusion embeddings will kind of start to match, so they can be used both for input and output. And because it's a language model and it depends on tokens, you can just kind of prompt it in a multimodal way. So you can basically combine a prompt which consists of language, of position embeddings, like little bounding boxes, existing images, and other sort of relationships in the whole sentence, which allows us to create an example like this, an anime drawing of a cat on the left-hand side of the screen based on this type of cat, and a dog on the right-hand side of the image in this style, or in based on this image in the style of this kind of Japanese anime, and yeah, it works. And they're in the paper, and they have a site on GitHub. It's actually an open source model, so you can download it and experiment with it. And there are tons of very cute and pretty impressive examples of going from photos to groups and to particular backgrounds, and from drawings to full photos. It can even generate video, although that's a little bit limited in the sense that it generates, I think, somewhere between 6 and 12 consecutive images, kind of a sample of the video. And they do beat a lot of existing models, including Flamingo, which already turned out to be not so good actually at multimodal, but also more recent ones like Lava and CogVLM pretty significantly on, and their own earlier model from July, EMU1, across the board on a lot of visual question answering tasks. So it can do quite precise reasoning about what's in the image. Mind you that on the multimodal or large multimodal models benchmarks, this MMVET GPT-4 vision has a score of around 60. So it's still quite a lot below GPT-4, but pretty impressive for an open source model. And in a similar vein, Google has just published this paper, VideoPoet, which is a very similar approach, but more focused on real video generation. So it doesn't just generate a sequence of samples from the video, but it actually creates the full video of, I think, 10 seconds or something like that, based on a similar architecture where you have these visual and language and structural tokens fed to an LLM core. And then on top of that, they have this video super resolution module, which actually kind of interpolates it into a smooth flowing video of 10 seconds. Also a site where there are a lot of impressive examples, but it's not open source. So, and finally, in the multimodal category, ByteDance, the mother company of TikTok, has just this week released their own video model called Magic Video. It's also pretty impressive. Check it out. So that brings us to from very large language models and multimodal models to very small language models.
Indeed, and I think this is a prediction that most people want to believe and want to invest emotionally in that we'll get language models that we can access more closely to our devices, like a mobile phone or even smaller, a smartwatch, a wearable, smart glasses, or even new hardware that will come out specifically for this.
Yeah, so this week in Las Vegas, Consumer Electronics Show, there was quite a lot of uproar about this sort of successor to the mobile phone, the Rabbit R1, right?
Yeah.
Which is just has one button and a language model inside.
Actually, it's not inside. It's nothing runs on device, but it's like a portal to a. They don't call it a language model. It's an action model that you speak to it, and it can do all kinds of actions like book an Uber ride for you, or find some navigation, or order food, or all these actions that you'd want to do from your phone or from pretty much an edge device with a power that has.
So why a special device if the language model doesn't even run on it? Why not just an app on your iPhone?
Well, I guess one selling point is that you don't pay subscription. You just have the device, and then all these capabilities come with the device forever, or for forever long the server's running.
So no subscription.
No subscription, yeah.
Who pays the GPT bills? Also Copilot, right? It's also not running on your device, but basically Microsoft has created the Copilot app and made it available for free. So basically it offers access to GPT-4 for free on your phone. So why pay 20 euros or $20 a month? And but I think the Apple and Google devices are aiming for this mini type of models actually running on the device, right?
Yeah, and this is where the most potential is, at least from what we've already seen announced and promised. Like Google says Gemini Nano will be running on their newest phones. And I assume and expect Apple to follow suit with the next iPhones. But maybe on a more speculative side, Apple Vision Pro surprised us that it's actually going to drop this February. And although they haven't promised anything yet in regards to AI, I think it's a very prime candidate for on-device AI that actually augments the experience and makes it a differentiating factor with other VR devices.
I think they have a lot of more hardware on the device than any phone currently available. So, well, there was, for example, Tiny Llama also launched, right? Like there's this category of 1 billion parameter models which do surprisingly well with the right training data and the sufficient amount of training compute.
Yeah, same as Phi from Microsoft. Although I find the naming kind of funny. Tiny large language models, which are 1 billion parameters that were huge bird models in a few years past.
Well, we live in a time of inflation, so who can complain? So you want to kind of gloss through these two papers, which kind of indicate where Apple is going.
Let's quickly go through them for the sake of time, but we do see evidence from Apple, who is increasingly present in the research space for language models, and this kind of makes me feel that they're preparing something. So specifically for this paper called LLM in a Flash, which got very popular on social, they're saying they based on observation on previous work that shows that large transformer models can demonstrate a high sparsity in the MLP layers, not the attention ones. And models such as OPT has up to 90% of neurons that never get activated. So they wanted to
it's also not a very good model, by the way.
Yes, I guess this is the reason why they chose it as a baseline. But they do show that if you target this property of large transformer models, you can combine it with smart techniques to retrieve large amounts of data and also minimize the number of times you do a call to the memory. And they pioneer this new way of storing some of the model in hard disk space, in an SSD on phones, for example, and only loading into the actual processor only the weights that will be activated. So they use this. They use three techniques. One is called the windowing, which is to do some smart caching where you, because this is another property that they have observed, parameters that have been activated for one token, it's very likely to be activated for similar tokens down the line. So they use this windowing technique. They also use a bundling technique where instead of calling the retrieval from the memory, from the hard disk, for the up projection layer and the down projection, they just concatenate and bring the whole thing together. But I guess the main point of the paper and the main innovation is this predictor layer, which basically takes the input of a layer and predicts which neurons will be activated. And we see that this does work. The concatenation of these three techniques brings significant advantages, and surprisingly, it brings almost no degradation in performance.
Right, it's like the classical cache prefetching predictor from classical memory, right?
Yeah, it's a lot of inspiration from traditional architecture and hardware.
And is it open source?
I think it is. I'm not very sure on that.
I'd be surprised. I bet it's patented, and Steve Jobs' ghost will sue your ass if you come anywhere close to it.
I know that the next one is, which does a pretty similar thing. This one is called PowerInfer.
Oh yeah, that's on GitHub.
Yeah, and this one pretty much tackles the same problem. They don't care that much about the efficient retrieval from and to SSD. They mostly care about this prediction, this accurate prediction of finding which neurons will be activated. Again, they're going off of previous studies that show there's a power law distribution where 80% of the activations come from just 10 to 20% of the neurons. And one of the main breakthroughs for this paper is you can actually vary the size of this predictor that does this job of finding the neurons. And there are layers specifically towards the end of the model that need much larger capacity to predict these activations. But earlier on, you can just get ahead with a very small predictor layer. And they show again, which is actually quite surprising to me, that for a number of architectures, can come up. Yeah. Yeah, for a number of architectures, and this one includes Falcon and Llama, and they show that it's kind of is a free lunch situation where you do this prediction, this specification, and all the required steps, and performance doesn't drop, at least for the benchmarks that they did.
Very cool. Yeah. I think we're moving towards our last predictions. By the way, tiny models, not only for language, but also for multimodal. MobileVLM is a recent release, has just been dropped between Christmas and New Year's on GitHub, and super fast rising in the number of stars. Our seventh prediction is that this will be the year of foundational models, not only for language and vision, but also for robotics. Google DeepMind just dropped this sort of vision website on their whole research program on robotics. And I think these foundational models are a very strong part of that. So this is paper called ALOHA. And some of that is driving actually off the advances of large language models. So obviously robots are also going to have world knowledge embedded from pre-trained textual models. But there's also this other approach, which has been pioneered by Gato and by RoboCat, where basically the models are able to very quickly adjust to different embodiments. So you can have kind of the same controller that's pre-trained, and it's kind of a foundational robotics model. And RoboCat showed that it can run on like many different types of robot arms. But I think this year we will be seeing that actually running in many kinds of mobile robots, from, let's say, drones to little mobile dogs and what have you. So there's, for example, this Octo paper that's going in that direction from the Berkeley robotics group. this Chinese paper towards learning a generalist model for embodied navigation, and a bunch of others. And who knows, not only foundational models for little robots in academic labs, but maybe even humanoid robots, but I doubt it. What do you think?
I mean, this has
Optimus
been promised again and again for the next year, and I still haven't seen it in a large scale. So maybe by the end of this year.
What about you,
If you're
Rodrigo? Did you
hopeful.
pre-order your Optimus?
I'd like to have one to do the dishes, but yeah, I agree with Dinos, maybe only at the end of the year or the next year.
So talking about doing the dishes, there's this very nice paper called Mobile ALOHA. It's not a humanoid robot entirely. It's more in this vein of collecting a lot of data that has traditionally been the bottleneck for foundational models in robotics, that there's only very small data sets. So this group at Stanford, led by Chelsea Finn, basically developed this kind of remote control semi-mobile version of their ALOHA system, which allows a human operator to very quickly collect many training examples of common household tasks, including doing the dishes.
Yeah, so this clip on the bottom went popular on Twitter, and everyone thought, "Oh, we're here. Everything is going to be automated." But
where can I order?
But in reality, the one we see on the bottom is teleoperated, as we can see from this figure here. So it's a human standing right behind it, just controlling the robot. But of course, this is very valuable data for the robot to learn eventually. But the task that currently this mobile ALOHA system can do is the ones you see on the top, which the most impressive one is the one that is storing a heavy pot in a cardboard. And then the rest is high-fiving people or storing chairs away, which is okay. Really nice.
Pushing the button on an elevator and then actually going into the elevator. I thought it was pretty good. It's a very small button. Yeah, I'm waiting for the bottom film to be there, maybe with Optimus. All right, so we're wrapping up. We still have a few predictions. We think everyone will have their own personal LLM. Well, in fact, it has been kind of accidentally released by OpenAI yesterday or
yeah, I
this
think
week?
2 days ago. Well, the GPT store came out yesterday, which is not exactly personalized. It's more a collection
of like your own prompt, right?
Yeah,
like
it's a
you
collection
can basically
of
have
prompts
a prompt.
and tools.
Yeah.
But also accidentally 2 days ago, there was this system pop up for some users, mainly in the United States, that said your GPT can now learn from your conversations. Of course, there's a lot of control what conversations you want to go in and not, but in the grand scheme of things, I think this is quite a leap forward if they find a way to effectively create a profile from the user and use it effectively to gear the generations towards that profile.
I hate people who remember everything that I've said to them. Let's see if this becomes popular. But personalization is definitely going to be a big theme in LLMs. Our second to last prediction is about AI for science, which has been kind of an eternal promise, just like self-driving cars. Just in the beginning of December, Google DeepMind came out with this news that they discovered millions of new materials with deep learning. Actually, there's been quite a hot debate on whether that's been completely debunked, because somebody ran some checks, and it turned out that there were slight notational variants of hundreds of thousands of materials which were already known, and there was zero net gain. Just now, on 8th of January, Microsoft published this paper, Accelerating Computational Materials Discovery with AI, where they have a slightly less grandiose but more sustainable claim that from about 500,000 material candidates for batteries, for electrolytes in batteries, they were able to distill it down to 18, which are really scientifically interesting. So who knows? And there's a Nature paper about discovering of a structural class of new antibiotics, which probably was submitted a while ago, but still, that's could be a major leap forward for drug discovery. And in fact, Isomorphic Labs, the drug discovery daughter of Alphabet, announced that they will at least get a lot of money for their drug discovery capabilities. So that will have some real world impact on their bottom line. And last, we think that a lot of companies are actually going to experience serious contribution to both their top and bottom line on the basis of using generative AI. So we've seen in previous year a lot of prototyping, right? Basically, if you look at the Fortune 500, all of them have had prototyping teams around generative AI. But in fact, some of the early experiments that came out, for example, this navigating the jagged technological frontier and experimental evidence for productivity effects of generative AI show pretty solid evidence that both the quality of AI-assisted work goes up, sort of the weaker and average performers get closer to the top performance for all kinds of fairly realistic office knowledge-related tasks. And also, of course, the speed improves by 20 to 40%. So we think that this is going to make a real differentiator in companies who are effectively jumping onto this and rolling out these prototypes to a much wider population and actually getting people to change their behavior and use them every day. And companies that are just keep experimenting and people just work in the old way. All right, so the working horse of a lot of this generative AI experimentation has been retrieval-augmented generation, right? Trying large language models to retrieval from your own proprietary data to give it up-to-date and confidential information. And if you're interested in that, obviously that's what we do at Zeta Alpha. But there's also a really nice overview paper that just came out last week, Retrieval-Augmented Generation for LLMs, a survey that's definitely worth reading. And it kind of explains the evolution that took place last year from a really simple sort of templating into the prompt into these very complex agentic and self-refining models that we see nowadays. So I think we have to wrap up. So we wish you again a happy new year, a happy 2024. And we wish that your AI and also your drone swarms will remain peaceful. Thank you. And if you're wondering when ChatGPT is coming, when GPT-5 is coming, I was searching for some predictions on that, but I found one which was actually on the OpenAI site. There's a link to it. This is the first result on Google. So if we talk about hallucination, I don't know. All right. So the next edition is going to be early February, again, live here from Lab 42. Thank you for attending. Thanks for joining us online. And now we're going to go for the part that's inaccessible to the online audience, which is a toast to the new year. Thanks.